Hello. Hi. In this video, we're going to learn how to reduce a radical expression that kind of contains the operations of addition and subtraction. This will build off of the previous video that taught kind of how to reduce a radical expression by extracting perfect roots. Okay. So you're going to need to know how to use prime factorization, and you're going to need to know how to reduce a radical from the previous video. All right, so if I scroll down, we'll get started here. The concept of adding or subtracting radical expressions is the same as combining like terms, okay? In the first little problem here of my table, I have a 5x plus 3x. And if we just combine like terms, you're just going to get an 8x. Now, for the second problem, we do it almost exactly the same way. I have 5 square roots of 2 plus 3 square roots of 2 is just going to give me 8 square roots of 2. Now, let me show you kind of what's happening here. If I have 5 square roots of 2 plus 3 square roots of 2, you're taking the coefficients and you're adding them together. You are not adding what's inside the radicals together. So ultimately, we're just collecting the number of square roots of 2 we have. We have 5 square roots of 2 in one group. We have 3 square roots of 2 in the other group. If you add those together, I have a total of 8 square roots of 2. Okay, so now the question is, well, what happens if those radicals aren't the same? Like the insides are not both square root of 2, then there aren't like terms. So how do we add these together? So if you take a look at my example 1, I have 7 square root of 12 plus 2 square root of 27. So I'm going to create a little bit more space for me to write here. Okay. And my goal is to try to get these to be the same. All right. So what I want to do is I want to break this first radical down. 12 is just 4 times 3, and 4 is 2 times 2. I'm using that concept of prime factorization. So right now I have 7 times the radical of 2 times 2 times 3. Now, if you watch the previous video, you kind of know that if I have a group of 2's, I can pull that out of a square root, and anything that comes out of the root will just get multiplied into the front. So what I get, ooh, hang on there, sorry about that. So what I get is I'm going to have, excuse me, let's get my stylist working here. I'm going to get a 14 square root of 3. Now, the 3 stays inside because there was only one 3 in there. We can't take the square root of 3. That's not going to be a nice whole number. Now, we reduced the first radical. Now, let's go back to the original problem. Let's reduce the second radical. So I have a 2 square root 27, and we're going to do the same thing. 27 is 9 times 3. We're going to break the 9 down into 3 times 3. Get my stylist working. All right, there we go. 3 times 3 times 3, right? So now I have a 2 times the radical of 3 times 3 times 3. Now, using the same rules that I did on the last one, I can pull out a 3. My pen doesn't want to write. There we go. Okay, so if I pull out a 3, I'm going to multiply that value times 2, so that's going to give me a 6 square root 3. Now that 3 comes from the one that was not circled. That's still inside. And I want you to take a look at these two radicals. Now, after you reduce them, I have 14 square roots of 3 plus 6 square roots of 3. And if you add those together, they are like terms. That is just going to give you 20 square roots of 3. Again, we add the coefficients, but we do not add what's inside the radical. Okay, let's go to example 2. So I have the cube roots. So instead of square roots, I'm dealing with cube roots. We're going to kind of go about this the same way. And I put in a little extra twist on this. I felt it was important. I have the cube root of a negative 54, right? So, we've learned previously you can't take the square root of a negative value, but you can take the cube root of a negative value. And if I do this, I'm going to show you. Ultimately, if you have a negative inside a cube root, your answer is just going to be negative, or that's going to reduce to a negative number. So I'm going to say this is going to be a negative 9 times 6. There we go. And I can say that this is going to be a negative 3 times 3. And 6 is going to be 3 times 2. And I'm even going to pull this negative 1 apart because I want to point something out to you guys. If I can get my pen to write here. There we go. Okay. Times 3 times 3. We have 3 3's. Okay. 3 times 3 times 2. Okay. And I'm going to put my radical back on there. There we go. Okay. So now I have 3 3's. So I can take that out. Also, I want you to understand, and this is a big idea here, the cube root of a negative 1 is still negative 1. Okay, so I can take a 3 out and I can take a negative 1 out, which is going to give me a negative 3 on the outside, cube root of 2. So let's see if we can reduce the other radical, right, using the same idea. So I have 2 cube roots of 250. If I break this down, I have 2 cube roots of, I don't know, what's this going to be? 25 times 10. I can break that down further. 5 times 5, 5 times 2. So I have 2 cube roots of 5 times 5 times 5 times 2. Now, I do have 3 5's. Again, it's a cube root, so we need a group of 3. That means I can take one of those 5's out, which gives me a 10 cube root of 2. And there was a plus sign between these two radicals. Now you can see that they are now like terms. I have negative 3 cube roots of 2 plus 10 cube roots of 2. That is going to give me a final answer of a positive 7 cube roots of 2. And that would be my answer. Okay, I believe I have a few more examples here. So example 3, same idea. We have 3 radicals, but we do it all the exact same way. Okay, so we're just going to reduce these. Feel free to pause it and try to do it yourself. But I am going to go through it step by step. If I were to take 5 cube roots of 8, this is 4 times 2. Try that again. Come on. I don't know why it doesn't want to write. So 4. Nope, still not wanting to write. See if we can erase it and go back. So we're going to break this down into 4 times 2, 2 times 2 times 2. So I have 5 times that radical. Now it's a square root, so I just need groups of 2. Means I could take a 2 out. I get 10 square root 2. That's the first radical. So let's see what we can do with the next one. So I have now break down 18 to 9 times 2, 3 times 3 times 2. So I can take a 3 out. That's going to give me a 9 square root of 2. And last but not least, let's do the last radical. This is 5 times 10. And then I have 5 times 5 times 2. And I could take a 5 out. So I get 5 square root of 2. All right. So again, I'm going to put my operations back in there. They all have the same radical. So if I do 10 minus 9 is 1 plus 5 gives me 6 square roots of 2. And that would be my answer. Again, just talking about how to add or subtract radicals. Number 4, I put an X in there. That's okay. Doesn't change how I do it. I'm just going to reduce it down. I want them all to be the same on the inside of the radical if possible. So if I break this down, this is 9 times 5 times x. don't forget about the x. I have a 3 times 3 times 5 times x. Again, we're going to take the square root of this, so I can take a 3 out, and inside I still have a 5 and an x. Okay, for the next radical, I have, if I have the square root of 20x, this is going to be 4 times 5 times x, or 2 times 2 times 5 times x. And if I take this 2 on the outside, I get a 2 square root 5x. Okay, and then last but not least, if I take this one, square root of 63x, I'm going to break this down to 9 times 7 times x, or 3 times 3 times 7 times x, and I can take a 3 out. Okay, so I have 3 radicals here. Now let me write this out so you guys can see it. I have a 3 square root 5x plus a 2 square root 5x plus a 3 square root 7x. Now, if you notice, only two, the first two of these are like terms. Those are the only two that I would be able to add together. So my answer when I do this is going to be a 5 square root 5x plus 3 square root 7x. Now, I wasn't able to reduce or to combine that last term because it did not have the same radical value. The inside had a 5x for the first radical. The last one had a 7x. Those are not the same. You can't collect those. The only terms we can combine were the ones with the same radicals. So let's try the last problem I have here, example 4. If I break this down, now I got a bunch of variables in there, but that's okay. I just want you to see how it works. So take your time, feel free to pause, try to understand what's going on, okay? If I have, see if I can get my pen working again. All right, still not working. Maybe I got a bad battery or something. Let's see what happens. All right, so let's say I have 5 times 10. This is 5, 5, and 2. And then I have 3 x's and a y, right? So let's see what I can take out of that radical. I have 2 5s. I have 2 x's. So if I remove those, remember, anything you remove has to go in front. So a 5 and an x. Inside is going to be a 2, an x, and a y. Those are the things that I did not circle. Okay. Now for the other radical, I have an x already on the outside. I want to break that 32 down. So let's see, 32 is 8 and 4. I can break this down, I think, to a bunch of 2's. 2 times 2 times 2 is 8. And then 2 times 2 is 4. And then I have an x, y. All right. Now, let's see what I can pull out of this. So I can take a 2. I can take a 2. So I can take 2 2's out. So on the outside, I'm going to have a 2 times 2 times x, and then a 2xy. So ultimately, I'm just going to write that as a 4x times 2xy, and I want to subtract these things. So what's 4x or 5x minus 4x would just be a 1x and then radical 2xy, right? So just combining like terms, 5x minus 4x is just 1x, and then the inside of your radical stays the same. So your problems won't get any more complicated than this. So the idea is one, do you know how to combine radicals that have the same radical, right? So we can add them together or subtract them. Inside stays the same. Now, if they have different insides, you need to break them down. You need to try to reduce that radical first, Okay, if you need help, please email me. I'll gladly assist you. But then after you combine those, or after you reduce them, you'll be able to combine any like radicals together. Now, we did have one problem here in example 4 where 2 of the 3 radicals were the same. You can combine those, but the third one was not a like term. Therefore, you had to leave it alone as its own separate term. Okay. Please try to complete the 4-problem homework assignment that I have after this, and I hope to hear from you soon.